So, Kevin, before we get started with today's minisode, I want to make sure that our listeners know kind of how Aerospace and Innovation Academy works a little bit with Blue Cube Aerospace and the Wolfpack CubeSat development team, since we're going to be talking a lot about these CubeSats that the WCDT has been involved in. So just for clarification, the Aerospace and Innovation Academy is kind of like a group where we work with our students after school. It provides opportunities for students who are interested in taking either Space Club or joining the Wolfpack itself. Now, I know that those entities operate a little separately. It allows us to liaise differently within the different companies. So like the Blue Cube Aerospace, you want to tell us a little bit about that before we get started?
Sure. I started Blue Cube Aerospace about 2010, 12, about 10 years ago when I was at the National Science Foundation with a friend. And the goal was to help educate teachers initially on the CubeSat form factor and what a good learning tool it was. And if we fast forward to 2015, I took a job in Florida at a middle school that was willing to let us see if we could build a CubeSat, design, build, test, fly a CubeSat with middle school students.
Right. So essentially, it sounds like you have had your background with Blue Cube Aerospace helped you to develop the Wolfpack CubeSat development team. And because of so much interest, we've created the Aerospace and Innovation Academy as a way to train students to be part of that CubeSat team. Is that correct?
That's correct. And now, because we have the AIA, the Aerospace and Innovation Academy, we're able to organize and conduct after-school programs, summer camps, workshops, educator PD. We prepare students for conferences, in addition to the work of the Wolfpack, which is primarily focused on design, build, test, and fly CubeSats. And we have LLCs, and we have a 501c3.
So that we can liaise differently. So that's important background information, because I know last week we talked a little bit in our first minisode, right? It was really about becoming familiar with the CubeSat itself, the history of the CubeSat, what it is, and kind of where it got its beginnings. And I think today you're going to tell us a little bit more about some important or instrumental CubeSat missions, or even just some interesting ones. Is that where we're going today?
Absolutely. That's exactly what we're going to do today. So for you guys on Zoom, we've transitioned to the putting up our slides.
You mean on the podcast, for those listening via podcast?
Oh, yes. And so today, the episode really is, I just entitled it Interesting CubeSat Missions, but there's a focus in two areas. The very first CubeSat launch, and then I picked out about half a dozen missions that I thought were very interesting for a number of personal reasons. But as we alluded to earlier, we're all about helping young people find their way. We've had some great success with YSAT and CapSat, and soon to be with FlipSat. And we have 2 more satellites in the pipeline. So we're always looking for students ages 10 to 20 that are interested in aerospace. So let's start with early CubeSat missions. So what we found, or what I have in my research, just to check it out, on March 30th, we finally, so I want you to imagine in 1999, there was a presentation that Bob Twiggs made at an early smallsat conference where he introduced this idea of a form factor. It still took them a few years to go to get some CubeSats built. And when they finally did launch, one of the first launches failed. The rocket failed, it exploded. But if we fast forward to 2003, the Russians, so you have to go back and think about at the end of the fall of the Soviet Union, they were hurting for money, and they also had a lot of intercontinental ballistic missiles, or ICBMs. So you could imagine a lot of folks that wanted to privatize and commercialize space industry. You have launch vehicles that are never going to be used for their intended purposes. So, you know, if you think about folks that own companies, they're always looking for a way to find another purpose or an application or save money. And even Elon Musk went to Russia 3 times at the turn of the millennium, trying to find somebody that would sell him an ICBM so he could go to space.
So, you know, automatically, probably because I'm an 80s child, we automatically think Russia, you know, kind of like from a military perspective. So is it safe to say that there seems to be some kind of defense part associated with how CubeSat's going to start in Russia?
Well, it's not that the defense industry was responsible, it's that there were missiles available and people needing money. So if you take the nuclear warhead off the top of the ICBM, now you have a rocket that can deliver any payload to space. And
I see. So because the technology was there because
Right.
of the Cold
The
War
military,
kind of stuff.
oh my goodness, yes. I think history shows us that technology really advances during times of war.
Mhm.
And it's exactly what we're doing now is taking these ICBMs, repurposing them, and they were carrying, I believe, the primary payload in that day, March 30th, 2003, were 3 satellites. But there were 6 CubeSats that tagged along for a ride, and that's why we call them secondary payloads. They're not the primary reason you go to space, but the secondary.
So Russia was setting this one forward in 2003. So it launched these other satellites, but also 6 of the first CubeSats, correct?
That's correct. And what's interesting is this rocket was literally called Rocket, a converted ICBM. It took off from Plesetsk, Russia.
ROKOT, though.
That's the rocket. And this was all brokered by a German company. So this German company brokered the deal with Russia. And so we went in, these 6 CubeSats went into a sun synchronous orbit, and they were launched from a P-pod. So for our folks that are joining us on YouTube, I found a little 30-second video of a Dnepr rocket launch. And what we're seeing is much like the US, the ICBMs are in a silo. And in the silo, there's some protection, right? And there's a charge that pops the rocket out of the silo above ground where it had been hidden, and then the rocket engine fires. So the engine does not initially boost the missile out of the silo.
It's like this thrust forward, and then
and then the engine engages. And you will see something similar if you look at video clips of, say, US subs that launch missiles, you'll see the same thing. There's a charge to get it out of the tube and above the water, and then the engine fires. So that was
So why, but before we go on with that, I really want to understand the whole connection from the historical aspect of Russia apparently launching CubeSats first. What were they seeking to do with those missions?
So the Russians were looking to make some money, right? They're hurting for money. The goal was to launch some communication satellites. If you think back to what we discussed in our first episode, the idea of CubeSats were great for a number of reasons, but whoever is paying the majority of the money to launch their very expensive payloads on the magnitude of hundreds of millions of dollars or more, they were concerned that CubeSats might damage or cause their mission to fail. And so the beauty of the CubeSat form factor was not just the size and characteristics of the satellite, but also the tube or the dispenser that deployed it, which ensured the CubeSats would not interfere with the main mission. So the early dispensers were called P-pods,
right?
Poly-picosatellite orbital deployer, P-pod. And that's exactly the kind of dispenser that was used for this first mission. So if you look at our first 6 CubeSats, you can see Japan, Denmark, Canada, and the US were the 4 nations that had these 6 missions. And they were all 1Us except for Stanford University launched QuakeSat. So what you see immediately is that nations that had very little or no presence in space are now launching satellites. So that was in 2003. And by the way, the QuakeSat from Stanford was about monitoring earthquakes. So if you notice, if we look at history now from 2003 on to the present day, you can see an exponential growth in CubeSat launches on the magnitude of 2,200, right? So these, we've really seen growth since, say, the mid 2010s because of, number one, the explosion of rocket companies and access to space. So that became a big driver. Now companies are raising hundreds of millions of dollars to build constellations of satellites for either mostly communications or imagery. That's the big commercial use of CubeSats.
So when they were originally deploying, they were concerned about whether or not when they set out the CubeSats, whether or not it would impact in a negative way the actual spacecraft. So once they tested that through the Russian one, it really kind of created a way for everyone else to do so, and obviously at a more affordable rate because these are smaller than what they had been doing previously.
Right. So I think it was a little bit of the needing the cash and the desperation that made the Russians a logical choice for early launches. But as you'll see with one of these images, if we look at who has launched the satellites, there have only been 55 CubeSats or so launched from Russia, whereas we have 1,500 from the US. So by far, that initial launch may have taken off from Russia, but the US has, obviously, the US currently is over 50% of the share of all nanosatellites launched. And so what you see is that Europe as a whole is about 25%, the US is over 50%, and then Russia is today only 2.5% of all the CubeSat launches. So that gives you an idea that all of the commercial activity where money is being made are from these companies in the US that are launching constellations.
Well, that makes sense because from a socioeconomic standpoint, I mean, the countries that are launching are countries that have money to do so.
Correct. So I think our viewers can clearly see a pie chart with the distribution, but bottom line is that even China being such a large space presence, compared to the rest of the world, except for Europe and the US, they represent less than 3% of all the CubeSats.
Well, we're talking about China for a second. I mean, I know that they do have a really active space, interest. Are they spending more of their money focusing on like outside of just CubeSats and like getting to other planets? And is that where are they spending more money on different like deep space exploration versus CubeSats?
My research, my reading indicates that China has a couple of goals. One, they want to be the dominant or a dominant superpower when it comes to space in the next couple of decades. They have really ramped up their crewed program, developing vehicles, developing their first space station. I think that they want to I think they would really like to beat the Americans to the moon in a meaningful, permanent way so that we can, the whole world is looking at, can we make money on the moon? If there is an economic reason, then we will live on the moon as long as it takes.
So it's safe to say that while it seems like their investment in CubeSats is small, not to be confused with their investment in
crewed, larger spacecraft.
Yeah, so larger, deeper space exploration.
Correct. Things that are rated for humans, space stations, spacecraft, landing vehicles, they're very aggressive in that area as well. Okay. So let's take just a quick overview of what's going on as far as the number of CubeSats launched through May this year. 2,286 nanosats launched. Those are on the scale, very small, just a few kilograms.
Is this, did you say from the world or from the US? I'm sorry,
no, this is the world.
Okay.
This is the world. And so there have been 2,300 approximately nanosats launched. And what we're looking at is 82 countries now have launched their own satellite via a CubeSat or nanosat. And the forecast is for over 2,000 of these small sats to launch in the next 5 years.
So that's a lot, right? So like with the little bit that I've learned from being with our group would be that seems like a lot of debris, right? When that goes up there. So do those burn up all of them? Do they just how do we prevent that?
Interestingly, I'm going to show you, we're going to discuss a little bit later on one of my favorite CubeSats that did deorbit. So deorbiting is an important consideration.
Yeah, there are whole companies that do that. I remember in our other podcasts.
So where you put a CubeSat, well, the energy of its orbit and its drag, the way its shape as it flies through the very top edge here in low Earth orbit will determine its lifespan. So let's look at some of my favorite, 5 of my favorite CubeSats. And so let's start with, I'll just do a quick high level briefing, and I recommend for the students that are listening that there's a lot of good information online for these, but let's look at GeneSat. GeneSat was one that I was originally interested in because as some of you know listening that Our first CubeSat actually was a biological payload. And so GeneSat was the first biological payload launched. It was created by NASA Ames, launched in 2006 into low Earth orbit. It was a 3U CubeSat, so that's about 30 centimeters long and 10 by 10 cross section. It flew E. coli bacteria, and it was the first automated biological payload that ran autonomously to look at the way E. coli bacteria behaved on orbit and how they produce proteins.
Did it grow faster? Did it not grow faster? What was the
So
result?
that's interesting. I was looking for some of the actual research data, and I couldn't find it. I could find where they have, the internet has archived the dashboard for GeneSat, but I could not actually find in my research for this episode the data from the experiment. So let's move to the second one. AeroCube, the Aerospace Corporation created the AeroCube satellites. Aerospace Corporation is in the US what we call an FFRDC, a federally funded research and development corporation. So imagine a nonprofit company whose primary and chief customer is the US government. So they flew these two 1.5U CubeSats that they, the joking name for them was GemSat and DougSat. And one of these little CubeSats, their goal was to fly in close proximity to one another. One would emit a beam and the other would detect it. So it was about precision pointing. Think about precision attitude control and pointing and proximity operations. So imagine it's one thing if you have a constellation of satellites. It's another thing if you can go and repair or refuel or even in a defense posture, protect your satellites with others. So the third CubeSat I want to mention is one of my favorites because I was at the National Science Foundation when this one was funded. It's called Firefly. And they took a shoebox-sized satellite and they flew it over the Earth, looking down at the top of thunderstorms. And they were able to determine and quantify and measure gamma ray bursts that are produced from very energetic thunderstorms.
So hold on. So the first one you said was a biological payload. With the one where they were sensing each other on the AeroCube, what kind of payload is that?
That would be validating new technologies.
Okay, and then the Firefly?
I would consider this a capabilities kind of exercise.
Okay.
So Firefly would be both remote sensing and generally what we call space weather.
So
right.
So payloads. So there's a certain kind of payloads, and so when you're choosing a mission, you're going to obviously have to pick the payload to kind of perform the experiment that you're doing. How many total payloads or kinds of payloads are there?
Well, the primary payloads are the big three that you might think of today are communications, remote sensing, and some type of internal science payload. Also, you can validate new technology.
Right. Okay.
Sometimes you have a combination of those going on. But
Fun
Firefly, I really like because normally you think gamma rays can only be produced by things like stars or supernova or things like that. But we find that even here on Earth, energetic thunderstorms produce gamma rays. So I've got two more CubeSats to quickly discuss. One is called Marco. Marco was the first interplanetary CubeSat. There were actually two of them. They were 6U CubeSats. They were launched in 2018 and they accompanied the InSight probe. So InSight was a probe that landed on Mars. It wasn't a rover. It didn't move. It landed and then it buried a deep probe and it listens for earthquakes. The problem is when InSight was landing, all the satellites that we have orbiting Mars were not in the right position to send back telemetry to Earth as to how the landing was proceeding. So what happens was InSight is landing, it's going through the Martian atmosphere. It's sending telemetry to Marco CubeSats that are passing by, and those Marco CubeSats send the data back to Earth. And it was very successful and our first interplanetary, Marco. The final CubeSat I wanted to share with you is called Capstone. It's a 12U CubeSat. It weighs, I think, about 55
What would
pounds.
that be a visual?
12U,
like
think 4x3 instead of a 1x1x1, 10 by 10 by 10 centimeter CubeSat. Think
like a mattress?
2 units wide, a face, a surface area of 4U, and then a height of 3. So imagine 4 3U
like a locker,
CubeSats
like a locker.
joined together.
Okay.
Yes.
So I'm trying to just to gauge a size of what that looks like.
I would
It sounds
say,
so much bigger, right?
I would say it's half to a third the physical footprint of a college refrigerator, like
okay,
a dorm
so it's way smaller than I was
Right.
imagining. Okay.
So Capstone is cool because we have parked it. It launched from New Zealand, and we parked it in something called a near rectilinear halo orbit near the moon. So where it is parked, it's using very little energy to stay where it is. And this is the first time that we've put any spacecraft in this kind of orbit. And what's going to be cool about it is it's going to be used with Gateway, our future Artemis missions to the moon. And it's going to be involved with navigation and communications, but it's a really good demonstration satellite. So those are 5 of my favorite CubeSats. And as you know, the Wolfpack, we have 5 of our own CubeSat missions or spacecraft missions that we can share about later. But those are some of my favorite missions and some of the early missions. And we look forward to you joining us for our next mini episode, where we'll be reviewing some of the subsystems on CubeSats.
Got it. So let me just give a recap and make sure that I understood. So essentially, we start with Russia, who has the technology at this point to use differently. They have these rockets.
They had excess launch. They had launch vehicles.
So to make money, they offered these rides up that could do these other things. And so we were then able to give that as the demonstration where other countries who might not have gone to space could start doing so, having learned from their mistakes, making sure that the deployer was safe and all of that, plus at a reduced rate. And from there, now we have all of these countries, even though not at the same amount, but who are able to fly some kind of payload for experiments into space, which brings it to why even a middle school can now.
That's right. The democratization of space means that you need lots of rides that aren't expensive, and the technology needs to be accessible. And that's exactly what's happened over 20 years, from 2003 to 2023. We have gone from only a couple of nations could go to space to highly motivated 12-year-olds. That's quite a jump in disruptive technology.
That was great. And I think I have a more solid understanding now, as I'm sure all of our listeners do as well. So sounds like next week we'll be exploring a few more of those. We hope you'll join us then when we say, let's go to space.